Hello and welcome to the wide world of physics. So on today's practical, what we're looking at is the concept of pressure. Now we're talking atmospheric pressure and vacuums, and I have a little way to look at it which is something of a magic trick. I will perform the trick first and then explain how it works afterwards. To do this, very simple. You need a cup most of the way filled with water, and you need some card. Nice and simple, you can get this anywhere. The bowl is quite literally for safety purposes. You'll see what I mean in a moment. To do this trick, you take the glass, pop the card over the top of it, and flip it upside down. Now you'll notice a little bit of water comes out, and that's okay. But if you then carefully remove your fingers, you can get the card to stay. That's the magic trick. It's not magic, it's physics, but we'll get into that in a moment. But here is how it's done. This process works on the principle of pressure, okay? There was a French physicist named Pascal who was alive in the early to mid 1600s. He was a mathematician and a physicist, and he did a lot of work with atmospheric pressure and pressure vacuums and so forth. So how this works, it really is just a glass of water. There's no trick to that. It is just a glass with water in it. And there's no trick to the cardboard either. What happens is when you flip it over, there's a bit of air trapped on the inside. Okay? So there's a bit of air trapped on the inside, and there's atmospheric pressure all around us. We live in a world of atmosphere because all of those tiny molecules of the air, oxygen, nitrogen, handful of other things, are weighing down. Each tiny little molecule has a little bit of mass. That mass adds up as you go further and further down. It's like diving into a pool. The lower you get into the pool, the more pressure you're under. You can feel that. It's the same thing with air. If you climb up a mountain, it's much lower pressure than if you are down at sea level, which is near enough where we are. So, at this point in time, there's a tiny little air gap in the glass. That air gap, when the card is placed on it, is now trapped in there. It's sealed. Water likes to hold on to itself. It's a property called cohesion. That's why if you take a drop of water and place it onto the table, it will kind of sit in a little bubble. It's a property called cohesion. Well, that water is cohesive, it sticks to itself, and it wants to stay together. So, as you remove your fingers from the bottom, what it's done is now use that property of cohesion to use the vacuum that's inside, which is a partial vacuum, and the pressure that's on the outside holding the card up. Now the reason the bowl is there is this won't last forever. So at some point in time this is going to drop, but more importantly, it's the concept that that air pressure pushes up underneath and holds that card in place, and the vacuum that's in the air gap helps to pull the card up as well. The combination is what gets that card to stick, and that is the work that Pascal did in the mid-1600s. Thank you for watching. I hope you enjoyed. If you liked the videos, please remember to like and subscribe and have a look at the other videos on the channel. Thank you very much and have a good day.